In this class, we're going to consider what a mathematical function is. So if you've never done functions before, probably the best way to think of it is a fancy version of a formula. A formula is just a rule which takes a number, does something to it, and gives you a new number. So it's like an input-output machine. It takes a number in, it does something to the number, and it gives you an output sort of value. That's essentially what a function is, at least as a starting point. If you've never seen functions before, just think of it as a fancy formula, a fancy way of expressing a rule, basically. The first thing is to figure out, how do we write functions? Well, we use a certain notation called function notation, which is normally f of x, like that. It doesn't have to be f, but f, f goes for function, stands for function, so f for function. But you'll see functions written with all sorts of letters. It does not have to be an f. When you're starting functions, you probably will use f initially. So let's say we wanted to express a rule which says, take your number, multiply it by 3. So a very simple function. That would be what the function does. That's the mechanism of the function. Well, the way that we would write that is f of x equals 3x. And what that's telling us is that this value here, the one inside the bracket, that is your input value. So that's going to be the number that you put into the function. And then what you get out over here is going to be the output value. Okay, so it's just this input-output machine. So as a formula, that formula is just saying to get your f of x value, you take your x value and you multiply it by 3. That's the rule. The rule, the formula, the function. Okay, so for example, if we start to put some numbers into that function, so f of 1, so remember that x is just a variable. It's just something you're allowed to choose a number for. So f of 1, that's 3 times 1, so that gives you 3. F of 2, 3 times 2, that gives you 6. And you can just carry on like that and do any numbers. You can do negative numbers as well. F of minus 4, 3 times minus 4 is minus 12. So very straightforward example of a function. One of the ways we visualize functions, though, is based on this kind of input-output idea. And we can take what we call, well, we call it a set of numbers, but just imagine a big collection of numbers there. And these are going to be all the input values for our function. And there's a fancy word for that, which we're not too worried about in this class, but that fancy word for that is the domain. That's all the numbers that go into the function. And then we're going to do the function. So this is your f function here, and this is all of your output values. Oh, I've broken my arrow, so arrow goes like that. So that's all the output values over there, and that's just a collection of numbers again. So to take the example that I just looked at over here, 3x, then we would write f of x equals 3x up there. And I'll just call this as well its fancy name, which is the range. Don't worry too much about domain and range. I'm just putting those out there now so that you have those in your mind already, but you can just think of them as inputs and outputs at this point. So let's take some of the examples we had over here. So we took the number 1, which was over here in the inputs in the domain, and we ran that through the function, and then we got the value that was the output value for that, which was 3 over here in the range. Okay, and then we took minus 4, which was a number over here in the domain, and that went over there. We call this a mapping, by the way. It's mapped over, and that mapped over to negative 12 over there in the output values. And that's basically all that a function does. It takes a value and it does something to it, and it gives you a new value. As functions get more elaborate, though, they'll do more and more things to a value, and then you get functions that are not just expressed like this, but are more, you don't really see the mechanism. For example, a sine or a cosine, a trigonometric function, or an exponential, logarithm. There's all these different families of functions, and sometimes it's not obvious what they're actually doing to the number, but they're doing something to the number, and that's how you get from your inputs to your outputs. So just to take maybe another example, let's have a look at the function f of x equals x squared minus 4. So similar-ish to the first one, maybe a little more complicated. If we start putting values into that guy, so f of 1, that would be 1 squared minus 4. 1 minus 4, that's minus 3. If we did f of 2, So 2 squared is 4, minus 4 is 0. That's fine. You can get an output value of 0. And you would just carry on in that sort of manner. If you did f of 3, that would be 3 squared, which is 9, minus 4 is 5. So these are all your input values, these are all your output values, and that's just how that function is working. And you could draw the diagram again to map over all of the points like that. But one of the key things to know about a function is that when you're making the connection between this number and this number, this one, this one, this one, this one, and like these guys over here, what you're actually doing is making pairs of numbers which form the coordinates when you come to draw the graph of a function. Now, we're not going to talk about the graphs of functions in this class. We do talk about it in another class, but this is just to put that out there because it's a really important point. When you make a graph of a function, and every different type of function makes a different graph, then what you get is effectively a collection of points. If you were to plot all of those points on an xy axis, you would just end up with the graph of the function. So to take this first one here, for example, let's just take 2 of those points and plot them on. So if we draw an xy axis, just really quick, I'm not going to get into this too much. I think we've established already that a function is just a rule that takes a number, turns into another number. All I'm saying now is when you pair up those numbers, you start to get these coordinates. So let's say that point there is at 1, 3. So 1 along, 3 up, which would be like there. The next point is at 2, 6. So 2 along, 6 up, which would be somewhere there. Turns out that this particular type of function, and they've all got different types, they've all got different labels. This is called a linear function. And the graph of a linear function, unsurprisingly, is a straight line graph. So if we were to keep plotting the points, we would just find that they form a straight line roughly like that. And indeed, all of the points would be lined up. So if we did minus 4, minus 12, that would be like down there somewhere, and that would lie on the line. That doesn't look quite accurate, but it should be somewhere on the line. I think the line should actually be a little steeper in reality. Same for this guy here. This is a different type of function. This guy is called a quadratic function. And in fact, the graph of this guy, I'll just do it on the same diagram. This guy would have a graph that looks something like this. So this makes a U-shaped called a parabola graph. So different families of functions will make different graphs, and we could see that on the points. If you started to plot these points, then you would just find that, for example, that would be the point there, which is at 2, 0, and then the point which is at 1, minus 3 would be this point down here. Point which is at 3, 5 would be like one of the points up there. So all of the points that you get from making the mappings between your inputs and outputs, making these pairs of points, they just make a graph. And that's one of the one of the really important ways in which we visualize a function, and we can gain information about the function just by looking at the graph. So a quick summary there, because I've covered quite a lot in quite a short space of time. So a function is just a fancy formula, and a formula is just a rule. So therefore, a function is just a fancy rule. That's really what a function is. It's just a rule that says, give me an input value, and I'm going to give you an output value. So 1 gets turned into 3, 2 gets mapped into 6, minus 4 gets mapped or turned into minus 12. If we want to go a bit further with that, we can start pairing those numbers up, drawing them on an xy axis, and we call that the graph of the function. Another example here, we're just making this number turn into that number. This one to this one, this one to this one, making those points, and we make a graph. We call all of the points that we put into the function the domain, all of the points we get out of the function, or all the numbers we get out the range. And that is essentially an overview of what a mathematical function is. If you ever see functions that are really confusing you, and you're like, oh, I just don't know what this even is, let alone what to do with it, just remember it's just a fancy rule. All that it does is turn one number into another. That's it.